with sir. Sir has helped us in guiding us through all the peer reviews and auditing, etc. And obviously, he doesn't need an introduction. Still, a formal thing from our end. So, Dr. Josna Kumar Mondal sir has worked as Vice Chancellor of Raiganj University. He has been conferred the Shiksha Ratna Award for Outstanding Performance in Education in 2018 by Higher Education Department, Government of West Bengal, India. Sir completed his MTech in Computer Science from Calcutta University in 1987, and he was awarded his PhD in Computer Science and Engineering by Jadavpur University in the year 2000. He is a professor of Computer Science and Engineering in Lien in University of Kalyani. Dr. Mondal has been former Dean of Kalyani University for 2 consecutive terms, Director of IQAC and Chairman CIRM. With 35 years of teaching and research experience in coding theory, data and network security and authentication, and many other subjects. Under his guidance, about 28 research scholars have completed their PhD degrees, 4 have submitted, and 8 are still pursuing. Sir has supervised around 3 MPhil dissertations, more than 80 master's dissertations, and 130 MCA dissertations. He is the guest editor of MST Journal of Springer. Sir has published more than 450 research articles, out of which around 190 are in international journals. He has published 12 books from Springer, Lab Germany, IGI Global, to name a few. Recently, Sir has published a textbook on reversible steganography and authentication via transform encoding from Springer. Sir has organized 55 international conferences and have edited 55 volumes of volume as volume editor. Sir has been a part of many granting projects, about 5 research projects where the grants have been received from AICT and Government of West Bengal. He served as Secretary IET Kolkata chapter, Chairman of CSI Kolkata chapter, and CSI Shiliguri chapter. He has been the part of a peer team of NAC accreditation process and an expert member of AICT EVC. Sir has conducted many different academic audits of various universities and institutes, including ours. So I know this was a very short introduction from our end. Without wasting any more of your precious time, I would extend the virtual mic to Sir. Over to you, Sir. Please guide us throughout the session. Thank you.
Okay, thank you very much. Thank you for nice introduction and good afternoon, everybody. So
Welcome, sir.
let us share my slide. Share this. Mhm. Oh, oh, sorry. Just 1 minute. So my screen is visible, no?
Yes, sir. Your screen is visible. We can see a list of files. Yeah, that is what we are seeing right now.
But the PPT is not visible.
Not yet, sir. We can see the list of files. I
Oh,
don't see the PPT.
but I have started. Let's see. Yep. Maybe some problem.
No issues, sir. We are waiting here. Maybe while sharing, you share the particular tab where that PPT is open. Then maybe we will be able to see. Sir, we can't see your screen yet. Are you sharing your screen from your end? I request all the participants to kindly stay in the meeting. As we all know, there are technical glitches happening in the online sessions all the time. So just wait for a few minutes. The session will resume very soon. Please stay here. Dr. Josna Kumar Mondos sir is joining. Sir, are
Now it's
you?
okay.
Sir, we can't see your screen yet.
Now I am sharing. Now I am sharing.
Okay, sir. Please. Okay. In the meantime, I request all the other participants to kindly stay muted while the session is going on. We will be opening
Yes.
the forum for Q&A at the end of the session. Yes, sir.
Just 1 minute.
Sure, sir. Sure. Yes, sir. We can see the
Now
PPTs
is
now.
visible, no?
Yes, yes, sir. Absolutely, it's visible, sir.
So I have changed from my tab to laptop.
Okay, okay. Yes, sir. Now it is in full screen and properly visible. Please, sir.
Okay.
Yes, sir.
Now, sorry for that inconvenience. It happens in the
No, no, sir. It's
just
absolutely
I see.
fine.
Okay. So now I think this is the session for IoT based communication systems and devices. So my lecture will be on security and authentication and ownership verification. Because you see that nowadays our IoT devices are increasing enormously, and you see we have the sensor and the actuator in the IoT devices. But beyond that, what is the main fantasy of each and every IoT devices? These are mostly connected devices. Now these are connected through a communication network. So if the devices are connected to a communication network, definitely there is a vulnerability of the communication network in terms of intrusion, in terms of man in the middle work, in terms of all other things. So now mostly we think of the situation that the all the IoT devices are the firmware, but there is a middleware of the IoT devices that control the devices and control the communications between the network, your peer to peer, and always from the head node to the sub node or to the leaf or to the through the communication channel. So anyway, we are communicating, and the thing is that as we are communicating, definitely there are a man in the middle. There are a lot of intrusion. And secondly, that when I'm sending the data or packets or the information or the data we are taking in the online mode from a sensor, the data is to be communicated to head node or to the server or to the laptop from the sensor. So when we are communicating, that means we are communicating through the open networks. Definitely we are using some signal, and we are just associating the data with that signal from the source end to the server end, and there we are just storing the data. So this communication is a vulnerable. That is the one major point. And this is one challenge, definitely. But what is the second challenge? The second challenge is that
Sir. Hello, sir.
yeah, yes.
Sorry to interrupt you, sir. Just one question. Have you changed the slide from the
No,
title
no, 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 no,
slide?
I didn't change. I'll
Okay,
come.
all right, all right. Okay, sir. Okay, thank you very
I'll
much.
come,
Sorry for the
I'll
interruption.
come.
Oh,
I'll come, no problem. uh,
okay,
so I'm just coming to that. So and this is a
okay, sir.
prelude
Sure.
of that discussion.
Okay, sir. Okay,
Now,
sir. Okay, thank you.
secondly, when we are talking about the security, now security in normal sense and security in IoT devices are not same. It is quite different. Why different? Because you see that most of the deployment of the IoT devices. So these IoT devices deployment, that it's based on the battery. That means not the normal power source. And if we have the battery, that means we have the limitations of the computations. So if the limitations of the computation is there, and you see that you have to go for a limited computing power to be taken for providing the security. That is also very important. So in terms of that, my discussion is here that what are the problem of your communication, what are the authentication, how we go for enveloping my information, and related objectives. So when we are talking about any communication systems, definitely the signals are there and signals are communicating. I'm not going to that. But if we go for the security aspects of the communication, so normally we go for two types of things. One is the cryptographic aspects. That means when I am sending the data from the source to the destination, or from the source to the server, or from the origination of the data or origin of the data to the server or the head node of a cluster, definitely we may conceal the data, we may authenticate the data, but definitely we have to keep in mind the consumption of the power in your computational device when you are deploying the algorithm. So when you are, I'm coming to that. So, and another thing is that, so you see, suppose we have a data, and I'm getting the data as a head node or a cluster head from the leaf of a sensor. That means sensor is taking the data, sensor is sending the data. So for that particular reason, you see that authentication is also needed. There may be thousands of sensors. Which sensor is sending the data, from where the data is coming. But if you have a private sensors, one or two sensors, that is this does not normally arise. So that we normally deal with the steganographic aspects. But in terms of the cryptographic aspects, when we are talking about that, it is a scrambling of the information that you are generating in the source node of the leaf node of the sensor. And you see, along with that key, we are scrambling the data, and the data is being forwarded to the online communications. And another thing is that it is called the authentication, and the you see the non-repudiation of the data. Suppose I'm giving the examples. Later on also I'll give some more examples. That here you see, you can see one leaf here. So that leaf, you can identify the leaf. And if I make a question and do a question that can you identify the leaf, so you can say that yes, I can identify the leaf. Now let us consider that I'm cropping the leaf, and it's only one petal is there. So if you say that can you identify the leaf, definitely you can say that may or may not be. So maybe. But again, if I crop it, you see that now if I ask the same questions, so what is your answer? That means no. But your technology says yes. That means technologically still I can identify. That means if your data have a problem, if your data has some cropping and other errors, still I can identify that this has come from these nodes, and that can be recovered in some ways. So, and that is called the authentication or non-repudiation or confirmation. So mostly why we go for all of these things, because this is one wrapper we are introducing in the communication between your sensor leaf node to the head node, or whatever, maybe to the server. That is because of that man in the middle, somewhere in the top of the wall, can see the both side of the wall. That means he can take the communications, he can change the communication. So that is why the cryptographic techniques, and that is a problem domain, and we are using the cryptographic technique. But in case of the sensor networks, we normally go for cryptographic technique, which is called the lightweight technique. What is lightweight technique? I can say that lot of, I think, talks it is their point. So lightweight means, you see that normally, you see we have two types of encryption systems. One is called the symmetric encryption, and another one is called the asymmetric encryption. Here we normally go for the symmetric encryption. What is the characteristics of a symmetric encryption techniques? That means we use a single key. Normally we use a single key, and you see both for the encryption and decryption, same key will be used. Key will be sent through a private channel to the destination node, and it will take the data, it will take the key, and it will decrypt the data on that particular session. So, and you see you see, that means key sharing is a matter here, that how you are sharing the key. If you may send the key through WhatsApp, you may send the key through mail, you may send the key through a private channel, but definitely the sharing of the key in any encryption techniques is a major concern. But you see that if you have a single key, you are sharing the key. But if you go for multiple keys, that means if you go for asymmetric type of encryption techniques, there are multiple keys are used. So when you are going for large computations, your available resource in terms of power and energy is more. In that case, you can go for asymmetric encryptions or the public key cryptography. What is the characteristics of public key cryptography? The characteristics of public key cryptography is that normally we have a pair of key, and secondly, prior to the beginning of the communication, you see, prior to the beginning of the communication, we used to exchange the key. Suppose we have a Diffie-Hellman key exchange algorithm or technique. We use that Diffie-Hellman key exchange algorithm and we exchange the key. But while you are exchanging the key, if the key is compromised and if the key is snatched by the man in the middle, which is the man in the middle attack, then again it will be a problem. So these are two scenarios. You have to take the optimal set of computations and type of encryption, and you see that then you can say that, sir, what is the problem? That when we are exchanging the key, there may be a problem. When exchanging the single key, there may be a problem. So then what is the ultimate solutions in the that recent trends and recent days? That means you see now from 2005 onwards, 2005 onwards, we have generated another methodology, which is called the neural computing or neural cryptography. Another field has been emerged, which is called the neural cryptography, where you see that we used to initiate some neurons in both end of the communications, and we used to um, train the neuron, and when the training is completed, both of the network will be identical, and from there we can generate the keys. No need of exchanging the key. But you can say that while you are exchanging in terms of the tuning of the architecture of the neural networks, that then there may be attacks. No, it is very difficult to attack, because you see, when we are exchanging a single bit, when we are you see just tuning the networks. So the neutral cryptography is most popular way of communicating without exchanging the key. So, but some minimum information we are exchanging. So encryption we have already discussed. Then let's go to the authentication. That means how do you authenticate? Then in lot of cases, most of the cases, you see, I am sending the data, or I am sending one of my angiogram of my heart to a doctor at USA. So how the doctor will know that it is my angiogram? So in between, in the man in the middle may change that data or the information of the file. So how do you authenticate that? That is your authentication. So normally in authentication, we never go for complete enveloping of the information. Instead of that, we used to generate a signature. What is the signature? That means, suppose this is one page of information. So from this page of information, we generate a fixed length code, which is called the digest, or I can say that this is a message digest. Now this digest may be sent separately through separate communication channels. This may be embedded in terms of invisible communications. I'll come to that in a later part of my talk. So a signature is an information generated from an existing information, and you see, this is always one way hash. That means I have some information and I am generating some signature. So this is normally called the digital signature. So normally you see, if you have some information, you can generate a digital. So your MD5 and your SHA1, these are two very popular uh, signature generation methods. Your MD5 generates 120 bits, but SHA1 generally generates 160 bit of information. So you can use this signature, you can embed this signature with your data when you are communicating the data, because you see that this is your sensor, so power consumption should be minimal. So in that case, you can embed that signature. Not necessarily that you can go for 128 bit. You can go for a small signature, small hash functions, and you can secure your data while you are communicating the data from the source end to the server end. So there may be some forgery here, or there may be some collision. So you have to avoid all these things. So normal authentications, we go for username, password. Nowadays, OTP is very popular. Public key algorithms have already discussed, and now some biometric methods we are using. So one of the authentication methods, when we are going for it, you see between your leaf or sensor nodes and the normal server, we normally use the password-based authentication systems. So here, along with the password-based authentication systems, we normally go for a salt added with the password. The salt is added from the server side to the client. So it is the computation from the server, not the computation from the sensor node or sensor leaf node. So what is the utility of that? The utility of that particular system is that the server is the salt. Salt means what is salt? It will be defined. So you suppose you have a very good pizza, and then you are sparkling the salt and pepper on the pizza to spoil the menu first, and then you used to eat. So here this is the salt. But when you are sparkling the salt and the pepper on the pizza, so it is spoiling. It cannot be. It is not a reversible process. But here it is a reversible process, because server is generating the salt, and salt is going to the your sensor node and for the authentication. In terms of authentication, if it is authenticated, now data is coming, communication is established, and server will deconcatenate the salt and it will authenticate. So this is another process of authentications. So now when I am going for, you see, sometimes your normal signature and signature based authentication may or may not be sufficient. In that case, we can go for some certificates generations or digital certificate generation. You see that in certificate generations, we normally use some information, that your documents or the data along with the digital signature, along with some timestamp, some public key, some private key, serial number, and a timestamp means that validity, how long the data is valid when you are taking the data. So now who is generating all these things? So if you can generate your complete infrastructure with your own, no problem, you can define all these things. But you see, this is not possible. This is a costly affairs, because you have to deploy all the mechanism with you. And that is why to facilitate with you, we have a public key infrastructure, so which is called the PKI infrastructure. We take the assistance of the PKI infrastructure for all our real day-to-day communication systems. So it is PKI. What is the PKI infrastructure? You see that this is your PKI infrastructure for every websites and all other things, all communication systems. We have a PKI infrastructure. We have a registration authority, certification authority, and verification authorities. So these are all third party. And you see that these are all trusted, and some governing principles are there from the RBI. So this is your PKI. We can use that PKI. So now my problem domain comes that we can use the cryptography. We can go for watermarking. You can go for steganographic application. Now in terms of the authentication, because you see nowadays we are using various sensors. All the sensors are taking the images, and images are being sent to the communication channel. Here, your steganography in terms of authentication plays a major role. What is that steganographic approach? So we can go for data hiding. That means it is an invisible communication, and it is a secret message transmission. It is ownership verifications. So here also I can go for copyright protections here when you are sending the data, uploading the data to a site. These are, I think I can skip that. These are some of the ancient steganographic approach. You see here, you see that head of, the hair of one person is saved, and here is saved, and this tattoo is made, and along with the tattoo some code is written, and after 1 month hair grows. He goes to the outside the kingdom and percolate the message. This is one of the example of the secret communication. So another, I think, let's see here. You see that this is a sweater. Now, if I can say that this is a sweater and design of the sweater, but if I say that this design is a code, maybe Morse code or other code, that means you see everyone is see that this is a sweater design, but who is intended, he can see that this is a code, he can read the code directly. That means this is called the properties of invisible communications. In Second World War, we use that type of communication. This is your posture detections that you can use in your steganography. But in digital form, when you are sending one image from a sensor to communication through a communication channel to the distant node, that means how do we authenticate in terms of the invisible communications? So that you can go for it. You see, these are, you see that normally what we do, that we used to engrap some code into the image where I am engraphing. That means lot of non-important regions of the images are there. So I can engrap that secret message there. You see, like this. And after embedding, you see that visibility will not change. Here we have a very clear distinction between the cryptographic process and steganographic process or hidden information communication process. In cryptographic process, what we used to do, we used to scramble the message directly, and it takes a lot of time, because what is the size of the message and size of the data generating from the sensor? So I have to take all the data, complete data set I have to take. Thousands of data are generated. So I have to take all the data. But in case of transforming an image in the form of image when it is generated from a sensor end, now I can use a small portion of the image, which part is not so prominent, or if I can distort a minimum delta x amount of the perceptive quality of the image. That is your steganographic application. And when you are sending, you see visibility in terms of image fidelity. Those who are from the field of image processing, they can understand all of these things. That visibility in terms of the image fidelity, visibility in terms of the SSIM, visibility in terms of the PSNR. You know that the PSNR of an image, if it is more than 30, 35, it is acceptable. So if I embed some information, not necessarily that you have to embed in all pixels. No, we are not going to disrupt the image. We are not going to distort the image much. In case of authentication, in terms of this sensor network, we can use a minimal portion of the image, non-prominent portions I can choose, and that will be a key to the receiver or the receiving side, maybe server or maybe receiving node of the cluster head, whatever may be. So there it can be authenticated in terms of extracting the code and comparing the code. If the code is embedded, that means it has to be again sent from some communication channel, other authentication channel. And then only we can regenerate and authenticate and ensure about the non-repetition of the image. You see, I am extracting, but there may be some problem of the quality of the image that we can address using the image enhancement technique. So this is called the steganographic technique. Mostly we go for authentication of the images. You see, I'm giving another example. Here you see, suppose we have a legal document. So what is the content of the legal document? We have some stamp paper. We have some word written documents, and we have some signature. So you see, if I transmit it, someone may change it. You see that the maximum has changed to minimum. You see, and the positive has been changed negative, and the strong has been changed to B. So definitely it is the original document, and the document is changed here. Now, what is the methodology? Now, suppose I am generating a message digest from this literature given here, and then I am embedding this as an invisible communications on this image, and I am sending this to the destination. At the destination, it is being received, and I am just generating again MD5 from this message, and I'm extracting the code embedded into the image, and I'm comparing. It is compared. That means this literature is okay, otherwise it's okay. That means this may be another methodology. Normally we use in legal documents and other things. So you see that this gold coin is embedded on this linear image. And you see, this is your original image and this is your embedded image. You see the perceptive quality almost identical. That means your image fidelity, similarity, structure, index metrics is same. And you see that your PSNR is also high. So that has to be achieved in terms of the metrics. So now your question will come that if I am taking a data from the sensor image data and I am extending my data across the network, so how do I achieve this invisible communication for authentication? You see, another word you have heard from your day-to-day use of your WhatsApp, you see, it is end-to-end encryption. There you cannot go for the end-to-end encryption. That is not possible in terms of your sensor network. Why? That thing is that WhatsApp is using the end-to-end encryption. The reason is that you see that it is a heterogeneous devices. My mobile may be the Apple mobile, your mobile may be one mobile or other mobiles, Samsung mobiles. That means the facility of the mobile algorithm available under the operating system for the encryption may be different. may not be available in both cases from X end to Y end. So that's why this WhatsApp they have made one techniques that when communication start, at that moment a negotiation will be done between the sender and the receiver. Negotiation what about? The negotiation about the algorithm available in both devices under that operating system of both devices, maybe two different heterogeneous devices. So one common agreement will come that out of 10 algorithms, I think 1 or 2 algorithms are common or 4 algorithms are common. They will choose the better algorithm among available 4 algorithms. And they will start encrypting and decrypting the message, exchanging the messages. And at end of the message communications, this end-to-end communication broken. No one knows what was the algorithm. No one knows what was the key of the size of the key. So now next time, same set of sender and receiver is communicating. So in that case also, another negotiation will be done. And another set of algorithm will be chosen, common algorithm, and based among that algorithm will be taken and communication will be done. So you see, this is called the end-to-end encryption process nowadays. Yeah, very popular in our days nowadays. So you see, when we are authenticating, we are extracting the embedded information always. So particularly when we are talking about the image and image processing and communication of the image from the sensor network, so we can go for it. We can compare for it, and definitely we can go for it. Image can be authenticated, source of the image can be identified, and non-repudiation can be justified. So what we can do in terms of the hidden communication systems, we can hide the data, we can go for secure image communications, we can go for invisible data transmission. So even through the image I can send the invisible data, even I can go for verification of the ownership. So now if I say complete techniques of the algorithm, so this screen is giving you the complete algorithm. We have some keys, we have some source images, we have some hidden data or messages for the authentication. Then we are generating an image which is called the stego image from the source or generated the image. Then it is sending to the communication end, and the receiver will receive and he will decode the messages from the images. You see, this earth image is embedded on this layer, and this is the embedded image. You see the difference between these two. These are, you see, almost same. Perceptive quality of these two images are almost identical. Again, you see this earth image is embedded on this paper image, and you see the quality of the image. So now this steganography or the authentication mechanism in transmission, we normally go both in your spatial domain and the your spectral domain. So I think I'm just giving a glimpse of it in a spatial domain only, which is called the LSB, and how it's sustainable, how much it can do good for you. That I'm suppose this is a Lena image. I'm taking 9 pixels from here. You see, these are the binary values of the pixel. These are the binary values, and then you see, I'm going to hide this. This is my authentication code, and this is my image. Let us consider that this is my sub image, and this is my code for the authentication. This is the code for authentication. Now, how do you do that? Let's go. I'm taking the LSB part. What are that? So you see, if I convert this number to the binary, you see this is 101101101101. You see, so all of this LSB part will be strip off. All of this LSB part will be strip off, and Here this data will be put here, this data will be put here, this data will be put here, like this. If it is in the row major order, you see, if we do that, you see this 1 is here, this 0 is here, this 1 is here, this 1 is here, this 0 is here, this 1 1 1 1, this 0 1 0 1. You see, I have stripped off all the LSB information here. So if we strip off the LSB information, what is the degradation? It is plus minus 1. Now another point is that, you see, I have strip off, you see, I have 9 pixel on that image. I have strip of 9 values. So how many changes occur? Let's consider. You see, first change is here. Second change is here. This to this. From 1 to 0, this is 0 to 1. Third one is here, 1 to 0. Fourth one is here, 0 to 1. No, that's all. Because you see, our system is a binary one. And in this binary system, you see, if 1 is replaced by 1, it is a no change. 0 is replaced by 0, it is a no change. Only 2 changes there, 0 to 1, 1 to 0. That means the probability of the change is 50%. That means not more than 50% bits are changed. And rest of the things are your adjustment, which technically it is called the handle. So you have to define your handle in a proper way. But here you see the change of the bit, the probability of the change of the bit. That's why the sustainability of the image, when we are going for image communications, and if you use the invisible communications or steganographic application in your sensor networks from source where you are taking lot of images in a paddy field or in anywhere in the remote sensing images, whatever, maybe sensor is taking various images, a video steganography or video analytics, anywhere, or crowdsourcing from the video, or you are detecting the crime from the video, whatever may be. So definitely you have to interface the videos, but definitely you have to authenticate that. So that authentication can be very easily, not all frames. You can go for the, if you talk about a video frame, if you talk about a video frame, your CCTV is taking the videos continuously and sending the data to you through a network. So you're taking the initial frame, master frame, or the first frame, you take some data, you embed some invisible information there, or the authentication code there. So at the destination end, it will be decoded that, and it will be compared with that, so that it can be authenticated and it can be non-repudiation can be achieved. So definitely when we are talking about this, so you see the change of the information is less than 50%. Because when I am changing, you see that you are changing only the LSB here, but I can use some hash functions to change some other bit. So if I perturb the higher order bit, if I perturb the higher order bit, definitely degradation will be more. But if I perturb the LSB, what is the change? It is a plus minus 1. So you know that when I am constructing an image or reconstructing an image, so single pixel does not contribute to much. Only the neighboring pixels are contributing much amount of that. So that is why you see you can generate this type of applications on the authentication code for your communication devices for this sensor type of things. So you see, this is another example that it is a 4x4 matrix. Yeah, you see, this is a 4x4 matrix. You see, these are the 16 bit of 4 byte of data, and I am embedding this. Here you see, I can show you that it is a multiple place. It has been embedded with some hash function. You see, yeah, like this. Yeah, like this. You see, 2 LSB. Here LSB plus 1, LSB plus 2, LSB plus 1 plus 2. Here you see LSB and LSB plus 2. you see that this is the embedding scenario. That means more robust sorts of algorithm you can use. You can generate the data from this most robust algorithm. That means the authentication can be done in terms of your communication. But definitely you have to think of the overhead, whatever you are going for a sensor. If you go for less computations in your leaf node or in the sensor node, and you can go for more computation intensive techniques in your cluster or in your uh, source node, definitely the life of your sensor will be more. Here you see, when we are talking about this, you see the changes here. This 78 is changed to only 76, and others are same. So definitely when we are talking about any communication system, security is must. Nowadays you see that when data is communicated, maybe from the sensor or maybe from your device or maybe from a computer file, so lot of attacks are there. So if attacks are there, definitely you have to prevent the attack. Various types of attacks are there, so you have to prevent all of these attacks. So in short, you see here, this is some of the methodology. I'm just discussing about the methodology for this. I think we can go for exchange of ideas now, so that we can discuss in that way. So I think so those who have any confusion and discussion, let us open the discussion and we just go for it.
Yes, sir, absolutely. So I would like to inform all the participants, you can unmute yourself anytime and you can ask the question, or you can
Yeah,
write it in the chat box.
chat box, so that we can discuss. That is better. So one way communication is not good always.
Yes, sir, absolutely. All the participants, you are urged to ask questions
Whatever
and
your questions, whatever your mind thinking, you please tell me so that I can discuss with that. No questions at all?
yes, sir, there is a question from Professor Onindan Mondol. What are the attacks
Please.
on steganography? The question is, what
Uh,
are the attacks on steganography?
Attacks. Okay, fine. Various attacks are there, particularly when you are talking about the image and you are dealing with the image. One is the rotation attack. Your image may be rotated. Your image may be cropped. Your image may be cropped. So in that case, you see these are the attacks, but these are sustainable. We have various algorithms to deal with that type of attack. Even you see the noise injection attack is also there. That means the attacker injects some random value impulse noise. So what we do, that we used to uh, reconstruct the image using some algorithm. That is also possible. Suppose 10% cropping, 20% cropping. How much? Based on your algorithm. Suppose 10% image has been cropped. You can regenerate that part of the image. That is very much possible.
All right, okay. Professor Mondol, I think your confusion is over. I mean, you have got the clarification. Anyone else, if you have any question, kindly put it up in the chat box. All right, sir. Another question from Professor Shayan Shortcut. If the
Uh,
algorithms are lightweight, won't they be vulnerable too? How to promise the security in that case?
no, lot of lightweights are there. All algorithms may be vulnerable based on the situation. But you see, for the lightweight communications, mostly it depends on the duration. When a sensor node sending a data, that means it's not communicating the data continuously. Once upon a time, it's sending the data when data is generated. So lightweight means that the algorithm is tight. That means the computational complexity is less. That does not mean that the algorithm standard is less. But there is a possibility or there is a chance to compromise that. Even in public key cryptography, there is a chance for compromising that when you are exchanging the key in public key cryptography or asymmetric key cryptography.
All right. Um, Dr. Sharkar, Dr. Shayan Sharkar, I think you have got your answer.
But
If any, yes, sir. Please continue.
and yeah, please. Yeah.
All right.
What is the energy availability and what the algorithm you can deploy? That means that optimization you have to think of that.
Right. Okay.
Okay. Please
All
another
right.
question.
Yes. Any other participant, if you're having any question, please put it up in the chat box. Whatever clarification you want, please put it up in the chat box. You can as well, I know, unmute yourself and ask the question. All right, sir. In the meantime, whilst the questions are coming in, I mean,
Yeah.
since this is an online session, I mean, had it been an offline session, it would have been great to have you in front of us and to meet and greet you.
Yeah, I'm
All right.
sorry because my examination is going on. I cannot leave
Yes,
my
yes,
department. That's why.
absolutely.
I've tried,
I
but I could not.
Yes, sir. Sir, we have another question from Dr. Ardhindu Kundu. Can
Yeah.
secret data be sent via images then by inserting
Yeah.
those bits in the image?
Yeah, absolutely. See, I have already written in a slide that is the secret data communication. That can also be done.
All right. Okay. Dr. Kundu, I think you got your answer. Anybody else, whoever is having any no, query, please put it up in the chat box. All right. As I was saying, I mean, had it been in an offline session, we would have been able to actually converse, sir. But since this is an online session, so we can only go for a virtual certificate. So if you allow, sir,
Sure.
I'll just share my screen for
Please,
once.
please, please go ahead. Please go ahead.
Okay. Okay. Thank you, sir. All right. Just a minute. Uh, is my screen visible? Can anyone please?
Yeah, it's visible. Absolutely fine.
Okay, okay, sir. So, sir, this is a very small token of appreciation from my end and our end, actually. And thank you so very much for this enlightening session. I mean, it was a very, very, very simplified and informative session. To be very honest, you explained each and every topic, each and every idea in such a simple manner that anyone and everyone can understand it. So thank you very, very much for today's talk, today's session. Thank you, sir. Please
It's
accept
my
this small
pleasure.
token
Thank you very
of
much.
appreciation.
Thank you very much. So
Thank you,
I
sir.
think I can give my mail. Anyone interact with that, they can go for it. Huh? Okay.
Absolutely, sir.
Right.
Okay, okay. We
Thank
will
you very
share it
much.
with
Bye all.
the
Bye
participants.
to all. Bye. Okay.
Okay,
Thank
okay.
you. Thank you.
All right. To the participants, with this, we come to the end of today's session. The attendance link has been posted in the chat box. So all of you are requested to give the attendance. Okay. And the assignment will be shared in the WhatsApp group in due time. Thank you very much. Thank you. This session will be on for next